Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 3 in the Information Disclosure module titled Source Code Disclosure via Backup Files. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portspeaker.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all labs, do a search on information disclosure, vulnerabilities, and then select lab number 3 titled Source Code Disclosure via Backup Files. Alright, let's get started. This lab leaks its source code via backup files in a hidden directory. To solve the lab, identify and submit the database password, which is hard-coded in the leaked source code. Alright, so the target goal over here is to first find the hidden backup file and then look for the database password, which is hard-coded in the leaked source code. Alright, so let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed through my Burp proxy. Alright, so when I'm looking for any directories that are not directly referenced in the application, what you could do is use a scanner like Burp in order to crawl the application and try to identify these directories. But another thing that you could do is see if the application has a robots.txt file. And it does, so you could see over here, the application has a rule that does not allow crawlers to look for the /backup directory. However, as a regular user who's visiting the application, you could just click on / and then visit backup. And you're able to view the content of the backup directory. So definitely you shouldn't be saving anything sensitive in the robots.txt file, and this shouldn't even be visible in the application itself. So you could see over here there's a file called producttemplate.java.back, and if we click on it, it looks like it's just a Java script. And if we look over here, you could see it makes a connection to a PostgreSQL database at the back end. The username is Postgres, and you've got the password right over here. Now, if this database was also internet facing, this would be disastrous because that means you could also access the database directly using these credentials over here. So let's copy this. And go back to the exercise. And while that's loading, let's just send our backup file request to repeater because we're going to need it when we script the exploit. So let's send this to repeater. Click submit solution, put it in here, click OK. And here we go. It says congratulations, you solved the lab. Alright, so we successfully completed the exercise by exploiting the vulnerability manually. Now let's script it in Python. So the first thing that we're going to do, as usual, is import all the libraries that we need. So the requests library, the sys library, the URL lib3 library, and the regex library. Next, we're going to disable insecure request warnings. So disable warnings, URL lib3 .exceptions .insecure request warning. And then we're going to set our proxy setting because we want all of our requests to be sent to Burp just in case we need to debug our script. So Burp is running on HTTP 127.0.0.1 port 8080. Similarly, we send all HTTPS traffic to the same place. So that's HTTP 127.0.0.1 port 8080. And then we'll define our main method. So we'll say if name is equal to main, then call the main method, and we'll define it right over here. So def main. If the length of the command line argument, so sys.argv, is not equal to 2, that means the user ran it incorrectly, and so we'll print the usage instructions and the example instructions. So we've got the name of the program and then URL. And we take the name of the program from the command line argument. Similarly, we print the example instructions. So the name of the program and an example URL, so www.example.com. And we take the name of the program from the command line argument. And the missing character over here. And then we exit the program because the user ran it incorrectly. Now let's assume the user did run it correctly. The first thing that we're going to do is create a sessions object. So we'll say request.session. And then we'll create an URL variable, and that'll be equal to the second command line argument. And then we'll call a function called retrieve database password. And that takes in the session object and the URL. Let's save that. Now this is a custom function that we have to create ourselves. So we'll define it right over here. So def retrieve database password, it takes in the session object and the URL. And then we're going to create a variable called back file URL. So the URL to the backup file. And if we go to repeater right over here, it would be URL of the main application plus this path right over here. Let's copy that and put it in here. And then we'll say r is equal to s.get. It's get because it's a get method. It takes in the back file URL. Set verified to be equal to false. And proxies to be equal to proxies because we want the request to be sent to burp. And then we're going to save the response in a variable called res. And let's click send over here, see if it timed out. It didn't. All right, perfect. Now the next thing is to confirm that our request went through. So we're going to say if r.statuscode is equal to 200. That means we did find the file. So you could see over here, the status code is 200. If the file didn't exist, we'd get a 404. And so we're going to print found backup file. And then we're going to create a variable called database password is equal to re.search. So we're going to search for it using a regex string, and we'll be searching through the response, so res. All right, so if we look down over here, this is the password. So let's copy that and put it in notes. Now, if we highlight this whole thing, you could see over here in Visual Studio, it's 32 characters. And so we're looking for 32 characters over here. And after the 32 characters, we're looking for the double quote sign. So over here, what I'm going to do is I'm going to change the quotes to single quotes so that it's able to search for a double quote. All right, so the 32 characters can be anything alphanumeric. So we're going to say it can be any integer. It can be also any lowercase letter. It also can be any capital case letter. So AZ. And we're looking for 32 characters, and then it has to end with a double quote. All right, this looks good. And then we're going to print the following is the database password, and we'll output the database password variable. Okay, let's save this. Go to terminal, new terminal, and then do Python 3, information disclosure lab 03, and just get the URL of the main application. Hopefully it didn't time out. So let's paste it in here and remove the trailing slash and hit enter, and we get an error. So it's on line number 8. Oh, and this should be a different kind of bracket. Right, let's save it again. Hopefully that's the only error. Let's run it one more time. And we get another error. So that's on line number 27. So when we're calling this function, and then it's on line number 17. So something's wrong with our regex string. Okay, so actually looking at the error, it's not the regex string that is the issue. It says it can only concatenate a string to a string, not to the output of this variable over here. And the reason is because we actually need to group it. So let's say group 0 to output just the first element instead of the entire thing. So let's clear it, hit enter, and here we go. So it says found the backup file. The following is the database password, and let's just add another double quote over here so that it's even when it outputs it. So if we run it over here again, you could see that it says the database password is this right over here. All right, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at another case of an information disclosure vulnerability.